Hello students, welcome back to Algebra 1. Today we're going to talk about graphing in standard form. Before we dive straight into that, I want to talk about the parent graph and some different effects that adding different numbers do to that. So I'm going to add a second graph here. And we already know what adding a number on to the end would do. So adding 4 just moves it directly up 4. However, in standard form, we have ax squared plus bx plus c. This would be the c number. What would happen if we made it a b number? So what I mean here is we have something like x squared plus 4x plus 4. We'll make that a little bit different, plus 5. What does this middle term right here do? Now I'll spoil the ending a little bit by telling you that it does move it horizontally. So if I do plus 4x right here, which way do you think it'll move? And how much do you think it'll move? Let's take a look. So it did move vertically, but I want to focus on just the horizontal movement right now. If I changed it to a 4x, it moves it to the left 2. So if I did minus 4x, you see it moved it to the right 2. So think about it for a moment. If I changed it from a minus 4x to a minus 6x, what do you think it would do? Minus 6x, you can see, moved the graph to the right 3. So plus 6x moves it to the left 3. So a quick pattern that we could see here is that what if I did plus 8x? You should be able to predict that pretty easily. It's plus, so it's going to move it to the left. And then you should have hopefully seen that the pattern is I'm going to take this number and divide it by 2. So this should move it to the left 4. And you were correct, it does move it to the left 4. So I'm going to go in the opposite direction as the sign, just like the other horizontal movement, and then I'm going to divide it by 2. Now, one of the other things is, what if there's an a value? So right now this a value is 1, but if I make this a 2, now it moved it back a little bit. So the 8 should have moved it to the left 4, but now it's only moving it to the left 2 when I change that to a 2. If I change that to a 4, now it only moves it to the left 1. And if I change it to an 8, now it's only moving it to the left 1/2. So this leads us to the formula of finding the axis of symmetry using standard form. So here's our first example problem, but before I get into that, I want to talk about axis of symmetry. So if I have a quadratic function in standard form, y equals ax squared plus bx plus c, the way I find the axis of symmetry is by saying x is equal to negative b divided by 2a. Now let's see how that applies to this one. Okay, so I want to graph this quadratic equation, and in this case I see a is 1, b is negative 6, and c is 5. So step 1 here is I want to find the axis of symmetry. So the axis of symmetry is found with x equals negative b over 2a, or in our case, negative 6 divided by 2 times 1. That would be positive 6 divided by 2, which is 3. So that means that I've got a vertical line right here that splits my parabola in half. Now I know on that line somewhere is the vertex. So step 2 is find the vertex. Now just like we did in intercept form, we find the vertex by plugging in the axis of symmetry. So I'm going to take my original equation, y equals x squared minus 6x plus 5, and I'm going to plug in my axis of symmetry. Y equals 3 squared minus 6 times 3 plus 5. So that'll be 9 minus 18 plus 5. 9 minus 18 is negative 9 plus 5. That would be negative 4. So that means my vertex is located when x is 3, y is negative 4. That would be down here. And then step 3, I'm going to draw the parent graph. On that vertex. So the parent graph is something that we've done a lot. I know that from the vertex, if I go right 1, I'll go up 1. And if I go right 2, I'll go up 1, 2, 3, 4. If I go left 1, I go up 1, and then I go up 4. And there is my graph. Now, there is a step 4 that doesn't apply to this one. And step 4 is going to be apply the vertical stretch. But in this case, the coefficient is 1, so there is no vertical stretch. So we'll deal with that in the next problem. Hey, look, this one's got a vertical stretch in it. So again, step 1, find the axis of symmetry. X equals negative b over 2a. So in this case, it would be negative 16 divided by 2 times 2. So that would be positive 16 over 4, which reduces to 4. So that means I've got an axis of symmetry right here on x equals 4. Now, where on that axis of symmetry is the vertex? Step 2, I'm going to plug it in. Y equals 2 times 4 squared minus 16 times 4 plus 35. Remembering my order of operations, exponents go first, so this would be 2 times 16 minus 16 times 4 plus 35. Doing multiplication next, 32 minus 64 plus 35. This would be negative 32 plus 35, which would be positive 3, which means my vertex is located at 4, 3. Just like that. Okay, step 3, I'm going to draw the parent graph. So that would be right 1, up 1, right 2, up 1, 2, 3, 4. And then I can mirror it with the axis of symmetry right there. There's my parent graph. Now, step 4, I'm going to apply the vertical stretch. In this case, there is one. So remember, with the vertical stretch, I multiply the y value. So right here, 0 is still going to be 0. But on the second point, I went up 1, multiplying that by 2, I'm now going to go up 2. On the second point, I went up 4, I'm now going to go up 6, 7, 8. And then I can use the axis of symmetry to mirror it on the other side. And there is my parabola. Okay, let's do one more example. Now this one looks the same, but you might see that there's something a little bit more difficult here, and we'll see what it is right at the beginning. Again, let's find the axis of symmetry. X equals negative b over 2a. And that's going to be negative 18 divided by 2 times 2, which is going to be negative 18 over 4. And there's where the challenge is going to come in right there. That is not a whole number. That is negative 4.5. So that means that my axis of symmetry is right here at negative 4.5. Okay, step 2, let's find the vertex. if I plug that in, it's going to be 2 times 4.5 squared plus 18 times 4.5 plus 42. This is a great time for a calculator. So I'm just going to type this in. 2 times 4.5 to the second power plus 18 times 4.5 plus 42 is equal to 163.5, which means I've messed up. Oh, I see it. I didn't put a negative in there. Okay, and then with negatives, you got to make sure they're in parentheses properly. Put the negative in there. Equals 1.5, much nicer. Okay, so that means 1.5 would be right here. Okay, step 3, draw the parent. So that means if I go right 1, which would be right there, it's going to go up 1. And if I go right 2, which would be right here, it's going to go up 1, 2, 3, 4. Like that. But then this one does have a vertical stretch on it. So I'm going to multiply the vertical movement by 2. So that means if I go right 1, instead of going up 1, it's going to go up 1, 2. If I go right 2, it's going to go up 1, 2, 3, 4, 5, 6, 7, 8 would be right there. We use the axis of symmetry to reflect it on the other side. Then we can draw our parabola. And that is how you graph a quadratic in standard form.